Salamun alaikum. Welcome to Journey of Understanding How Computers Interpret Python Code. This guide will help you as a beginner programmer grasp the essential concepts of computer architecture and the transformation of code into binary language of computers. By the end of this script, this session, you will be familiar with the step-by-step process that turns your Python code into machine code ready for execution. So now let's start. So table of contents, we are going to discuss about the binary and machine language, understanding the binary conversation, the Python code, compilation process, variables and data types in Python, binary operations and their importance, a real world application, building a simple calculator. That is not this session, but in future we'll discuss about that. Now, introduction to binary and machine language. Binary is the fundamental language of computers, consists of only two digits, 0 and 1. Example: the decimal number 5 is represented in binary as 101. How computers interprets instructions? Computers convert high-level programming languages like Python into binary machine code for execution. This transformation involves several steps including lexical analysis, syntactic analysis, and bytecode compilation. So, significance of binary in computing: binary serves as the foundation for all computing processes, determining how data is stored, transmitted, and processed. It is essential for optimizing code performance, especially in data heavy applications. So, now we try to understand binary conversation. Identify the decimal number. Start with the decimal number you wish to convert. For example, let's take the decimal number 5. Determine binary representation, which breaks down the decimal number into powers of 2. For 5, it can be expressed as 2 to the power of 2 plus 2 to the power of 0, which equals to 4 plus 1. So construct the binary format, represent the power of 2 using binary digits, zeros and ones. For 5, this results in the binary representation of 101. Visualize the conversation, create a visual aid that shows the relationship between decimal and binary. For instance, a chart can illustrate how decimal numbers from 0 to 8 correspondent to the binary equivalent. So I did not have the chart yet, but you can just imagine that the Python code compilation process. Writing the code, be, begin by writing Python code in a text editor such as print hello world. Next step is lexical analysis. The Python interpreter breaks the code down into manageable pieces called tokens. Syntactic analysis. The tokens are analyzed against Python's grammar to ensure they form valid statements. Bytecode compilation. The next thing is, once they conform, the code is compiled into bytecode, which is a low level set of instructions. Next is the execution. The bytecode is executed inside the Python virtual machine, that is nothing but PVM, converting it into machine code, the binary language of computer. Next part is variables and data types in Python. Understanding variables. Variables are names that hold values in Python, allowing for data manipulation and storage. Data types in Python: example, integers, floating points, and strings. Binary representation. Each data type uses varying amounts of memory stored in binary, which is fundamental which is foundational for data processing in computing. So binary operations and their importance. Now try to understand binary operations. Basic operations enable efficient calculations and data manipulations. For example, 1010 plus 0011 is equal to 1101, that is decimal 13. Similar rule to decimal addition with the carryover when the sum exceeds 1, right? Foundational for data storage, transmission, and processing, that is significance of binary code. Essential for optimizing code performance in data heavy applications. In understanding binary operations, real world application is crucial for effective programming and system performance. So, writing code, for example, begin by writing a simple Python program to add two numbers. For example, number 1 equal to 10, number 2 equal to 3, then sum is equal to number 1 plus number 2, print sum. Then the Python interpreter processes the code by breaking it into tokens. It checks these tokens against Python's grammar to ensure they form valid statements. Once the code is validated, it is compiled into bytecode. Bytecode is a low-level set of instructions that Python virtual machine can understand. So that's it. So what we have understand so far, understanding binary and Python code compilation process, variables and data types, importance of binary operations, optimizing code performance. So we'll see you in next session. Thanks for watching.